All right, this is part 2 for the sum of difference of two cubes. Okay, and this is the actual part that's factoring the sum or difference of two cubes based on what you are given in the way of terms. So whenever you see a to the third or x to the third or anything that's divisible by 3, you need to double check to see if any of the numbers are if you cube root them, if they'll simplify. And if they do simplify, then that's actually could possibly be a cube that you can work with. All right, now these are the formulas. Whenever you see, a cubed plus b cubed, anything along those lines, you can break it down into this format. Now, if you have a negative sign in between, you can break it down to that format. Okay, now factoring this by hand, it is a bear. It's easier to memorize these formulas. Okay, and I've also included as to an optional video as to kind of where this formula comes from. If you were to use long division, you would end up deriving this formula. Okay, but for the purpose of online learning, I'm just going to show you right now that you do need to memorize these formulas. The easiest way to do that is to go ahead and kind of see what the sign pattern is. I've got it down here, but I'm just going to rewrite it underneath here. If you do have a plus sign, we would start with our plus sign here, okay? And then you're always going to have one negative and two positives. So if you start with a positive, the next one's going to end up being a negative and a positive. Okay, so you're going to have a, b together, and then a squared minus 2ab plus b squared. So you're going to end up with kind of like a negative sandwich if you want to think of it like an Oreo. Okay, so that's one way to remember it. Okay, that's only when you have a positive. So when you have a positive, you're going to start off with a positive, and then you would go ahead and finish it up. So positive, negative, positive. But if we start off with a negative, okay, then we're going to end up starting off with a negative. Okay, so kind of like if you think about if you have a really great morning, it's a positive morning, you're going to continue to have a positive morning. And if something happens in the middle of your day and it kind of brings you down in a negative way, and towards the end you'd end up kind of leaving off on a good note, hopefully. All right, that's in a good world. Now, if you wake up and you're on the wrong side of the bed to begin with, okay, or you wake up and something's not right or your alarm clock didn't go off, okay, you're going to start off on this negative kind of morning routine. Hopefully it is going to get better. So we're going to end up having a better moment, and then all of a sudden you're going to end on a good note, hopefully. That's just kind of like a silly way to kind of remember your signs as far as how it goes. And then you will need to memorize what goes on the inside. Now, for the purpose of digital learning, you're going to see this again next year. When you're practicing, go ahead and have these formulas in front of you on the Khan Academy assignments whenever you see a sum or difference of two cubes. You're not going to have a quiz or an assessment on this. You're strictly practicing at this point. You will see this again next year, and you'll be assessed next year on it. Okay? But you're not going to be you're not going to be expected to memorize all of these things, because I've already told Miss Ramirez next year that what she needs to go over and what I was able to go over using digital learning. Okay, so here we go. Let's go ahead and start off with factoring. I'm going to leave these formulas up here so you can kind of see what's going on. Okay, right now I have a sum of cubes because once, number one, okay, there's a plus sign there, so I know I'm going to be working with this formula right here. I'm going to erase everything so I can kind of just visualize what's going on without everything going on, everything else. All right. So much. Okay. Now, I need to look at this first term. 2 is not a cube. Now, just like we did on part 1 when we talked about squares as far as 2, 4, 9, 16, 25, 36, we need to talk about our cubes. And when I work out those cubes, it's better just to kind of have a running list on the top. Whoops. Okay, and that running list would start off with 1 cubed, which would just be 1. 2 cubed is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 64. 5 cubed is 125. Okay, and we can continue on, so on. All right, so looking at this, I know 128 is not a cube, okay, and 2 is not a cube either. So we need to see if there's a greatest common factor we need to factor out. Okay, greatest common factor, they are both even, so I'm going to go ahead and divide out a 2 from both terms. That would leave me with y cubed plus 64. Okay, and don't forget to your GCF needs to stay on the outside. All right, now at this moment I have two terms. Come on. Oh, well, we're going to stick with green. Okay. So we're going to go ahead and start off with looking at the first term. Now our first term is y cubed. So just like when I did the squares, I'm going to kind of see what this is cubed. Okay, so what cubed gives me 64? We already talked about that up here. 4 cubed gives me 64. Okay, now that's going to identify what A and B are going to be. And so if I know that A equals y and B equals 4, I can go ahead and substitute it into the formula that I already have up here, okay, which is just A plus B. So I'm going to end up with y plus 4. And our next part is A squared, which would be y squared minus 4 times, A times B, which I can change them around because the multiplicative inverse basically states that I can multiply either way. So 2 times 5 is the same as 5 times 2, and it's a rule that allows us to move things around. So instead of writing y times 4, I'm just going to write 4y, just because it's standard. Okay, coefficient in front, and then we're going to end up with plus b squared. B squared in this case is going to end up being 4 squared, which is 16. All right. Now, when you're using when you're using sum or difference of two cubes, okay, there's nothing else we can factor out here. Oh, don't forget, here's a common mistake, and I almost made it. Don't forget your greatest common factor needs to stay out in front. Okay, so don't drop that. All right. Usually what I was saying is that you can't factor anything else out here. Okay, so you can try, but multiples of 16 that'll add up to give you 4, there's none. All right, so that's fully factored there. Let's go ahead and take a look at this next example. Okay, this next example, the first thing that I realize or I recognize is the fact that there's a negative there. All right, I also notice that these numbers are perfect squares if I were to continue on. So if I were to continue on and say, okay, 6 cubed gives me, and I'm going to have to use a calculator because it's 6 times 6 times 6, 6 cubed gives me 216. Let's try 7 cubed. Okay, so we're going to start off, have 7 cubed, and that's going to give me my 343 that I'm looking for. Yay! All right. If not, I would have had to divide out a 2, see if I can go any further than that. Okay, so now what I'm going to do is I'm going to go ahead and rewrite it so that I can figure out what A and B are. So I'd figure out A cubed, which in this case we already know is going to be 6 cubed, and then this is going to be B cubed, which is just 7x. All right, next step is I've identified what A is, which is 6, and B is represented by 7x. And I can go ahead and substitute that into my formula. And the formula is up here. It will not let me pick another color. Interesting. Okay, but we're going to go ahead and substitute in, and we're going to start off with A minus B, which would be 6 minus 7x as our first step. Our second step is going to be A squared, which is 36, plus A times B, which is 6 times 7, which is 42x. And the last step is B squared, which is 7 times 7, which is 49, times x squared. All right, do not distribute this out. If you distribute all of this out again, it's going to give you this final answer. You stop right here. I know a lot of students last year had that question. Well, what if you continue to multiply that out using the box method, or some of you guys like to call this FOIL, but you got to watch out. It's actually the distributive method when you have a trinomial times a binomial. Okay, just stop here. You're good. Okay, all right, we've got 2 more problems. I'm going to go ahead and work those out. We are working with a, difference of, difference of cubes, and we're going to go ahead and take a look. So with this, we have 8 and 125. 8 and 125 are both on our list, so we're going to go ahead and write those out. So what cubed minus what cubed? This is just going to end up being 2x squared to the 3rd power, because 2 times 3 gives us that 6 exponent that we're looking for, and then what cubed would give me 125, and that's just 5. All right, so I know now that A equals 2x squared and B equals 5. What I would do next is go ahead and set it up. I know it's going to be negative, positive, positive inside, and that's going to be 2x squared minus 5, and on the inside over here we're going to end up with 2x squared. Okay, and remember that part needs to be squared. So just in this first step, notice how right here I need to square it. What you could do is go ahead and write down the formula first. A squared plus AB plus B squared. Okay, so in one of these steps I'm going to go ahead and just put squared, and then I'm going to simplify it down here. And then A times B, which would just end up being 2 times 5, which is 10x squared. And our last one is 5 squared, which is 25. Last step is I'm going to simplify that term. So we have 2x squared minus 5. Keep that. This becomes 2 squared, which is 4. X squared squared just becomes x to the 4th power plus 10x squared plus 25. Close parentheses, and you are all set. All right, last one. So looking at this one, I noticed right off the bat this is an odd number, and I can only really factor when they're even. So what we're going to do on this one is we're going to see if there's a greatest common factor that I can divide out of both of those, which x would be our greatest common factor. So I'm going to put x on the outside, and on the inside I'm going to see whoops, I need some parentheses. So x and then a bracket. That would leave us with x to the 6th minus 64 and then not x. All right, so when I break this down one more time, okay, x squared cubed minus 64. The cube root of 64 is just going to give us 4 to the 3rd. Okay, so another way to write that is 4 to the 3rd. So that gave us what A is and what B is. We can go ahead and substitute this into the formula that we already know. Okay, don't forget to bring your greatest common factor down. Okay, something a lot of people, even myself, sometimes forget. So it is a difference of squares, so I'm starting off negative, start off another negative. I'm sorry, it already is negative, okay? Then, so I have one negative, positive, positive. Only one negative in the mix. All right, so I'm going to start off with A is x squared and B is really just 4. So x squared minus 4. And then we're going to end up with on the inside x to the 4th plus 4x squared, and then on the end is just x squared, or 4 squared, which is 16. All right, now we do have a difference of squares right here, so we do need to continue on. So it's going to be x plus 2 and x minus 2. X to the 4th plus 4x squared plus 16. And that concludes our video. If you have any questions, please let me know. Always remember, you can possibly need to factor in more out. Please email me if you have any questions, and I can go over anything on Zoom. Thank you. Bye.